Welcome, Math 8 mathematicians. Today we're going to be looking at the exterior angle theorem, which has to do with triangles. So we are continuing our Transversals and Triangles mini-series. Our learning objective today is to learn why the exterior angle theorem is true. That's kind of maybe a subtle theme of this mini-series, but really important that we prove to ourselves why things are true. And we're going to look at a couple examples of how to apply it. Let's get started. So I have the same setup here that we saw for our interior sum of our, the sum of our interior angles of a triangle. So notice again, I have this triangle on the inside. I'm going to highlight him real quick in orange, or just outline him in orange. So I'm looking at this guy is the one that's looking at our interest right now. Nothing special about this triangle except that it meets right up here. It has a vertex, and we have a parallel line that's parallel to the base of our triangle that's through that upper vertex right there. Otherwise, we've just extended the sides of our triangle to make transversals, and then we call one of them parallel lines. We're going to go ahead and get started just the way that we did with the other one. The first thing that we want to do is we want to give some names to our angles. We have some unknowns in here, and we say, hey, we're interested in the angles of a triangle. You better name them. So, really creative again, we're going to name them A, B, and C. Just our basic generic names for angles. Alright, so we have triangle. We have angles A, B, and C. Now we talked about finding the exterior angle of a triangle. The exterior angle of a triangle, these are all interior because they're contained inside the triangle. Exterior is going to be something that is outside the triangle that we might see. So I'm going to show us some exterior angles that are in here. For example, there's this guy. This one would be an exterior angle. That's not how we spell exterior. Because he's a supplementary angle. He's making a 180 degrees with A. So it's like we extend one of those sides from the triangle, and it's exterior. This would also be an exterior angle, and you might notice I'm going to draw it the exact same way, especially since they are vertical angles with each other, so I know that they're actually going to be the same exact measurement. They are congruent to each other. But I have lots of exterior angles that I could see on here, so I'm going to extend one side over by my C, and I could say, hey, well, that's a highlighter. That's what I conclude. I could say, hey, this is an exterior angle over here. Exterior angle. And again, I have my other one. If I were to expand the other side or extend the other side of my triangle, I get another exterior triangle. And as you may have guessed in that chaos next to B, we still are going to have two exterior angles. So there's going to be one right over here. This is our exterior angle on this side. Again, I've extended out that side along that transversal. So I'm looking at that, and then I'm going to kind of ignore that parallel line that we threw in there. And then the same thing with its vertical angle. This is my other. So we're going to just focus on one of these, but every triangle that we look at does have 6 exterior angles to it. And that's going to be 6 groups of 3, I guess you could say, or 3 pairs of exterior angles, because those are all, as we saw, they have pairs of vertical angles in here, which are going to be congruent to each other. Alright, we're going to focus in on one of these. So we're really going to pay attention to that first one that I labeled, because why not? It could be any of these, but we just want to clear up in our heads, you know, this could be an angle, the angle, and the triangle, and we'll look at others in a moment. But we want to just look at this exterior for a moment. So the first thing I want to talk about with this exterior angle is that, hey, I already know that because this all the way across is a straight angle, it is supplementary to A. So in other words, I know that let's find some room over here, exterior angle, the measure of my exterior angle, plus the measure of angle A, again, I'm being a little loosey-goosey with my notation, but that's okay, has to be equal to 180 degrees. However, we saw from our interior angles that we know something else that has to equal 180 degrees. All the interior angles of a triangle add up to 180. So the measure of angle A plus the measure of angle B plus the measure of angle C, purple for C, also equals 180. So I can set these two things equal to each other. 180 equals 180. So why not? So what I'm going to do is I'm just going to go out to the side here, give myself a bit of room, and I'm going to continue writing this. 180 equals 180, so I'm going backwards. So that's equal to all of this good stuff right here. I'm going to copy and paste it. Great, wonderful. Well then from this equation, I'm going to circle it, I'm going to pull it out so we can really focus in on this. We have this equation now, by combining those two, I see there is a measure of angle A on one side, there's a measure of angle A on the other side. Let's get rid of them because we can do that. Cancels, cancels. I don't really need this equal 180 over here, so we're just going to simplify everything, and we find that we can change the color of our pen at occasions. No. What do you want from me? Sometimes this guy just doesn't really feel like changing on me. Alright, the exterior angle is equal to both of these angles. Angle B plus angle C. So let's look at what that shows us actually on the graph, on our diagram over here. So it means that if we look over here, the exterior angle right over here, that exterior angle on that side, is actually equal to the sum of B plus C. So it's those two angles that are kind of opposite of it, that are furthest away from it in the triangle. And we have names for those. We call these remote. Remote meaning far away. And of course they are interior angles. So this lets us conclude. Let's get a conclusion. We need a conclusion here somewhere. Bam. An exterior angle of a triangle has the same measure as the sum of its two. Ooh, I'm running into some room here. Two remote interior angles. And you can show this is true for any of them, right? So we looked at just the exterior angle that's next to A. You could show the same thing for the one that's next to C, how that has to be, again, it has to be the supplementary to C, and we know A plus B are, and you can do the same thing with B as well. If I drew that exterior angle against B, again, it has to be supplementary, and we know A plus C are supplementary to B. So this is our big conclusion, that the exterior angle has the same measure, the sum of its two remote interior angles. A little bit of fun new vocab for us. We have exterior angle, exterior exits the triangles outside of the triangle, and the interior is in the inside of the triangle, meaning far away. So let's put this to work. We have two examples to go through. The first one over here, we say we're going to solve for x. I notice I have right over here, this is my exterior angle right here. We're looking at the pink triangle, and this angle is outside that pink triangle. It is supplementary to one of its angles right here. And I look, hey, both of these are the two inside angles that are furthest away from our exterior angle. So those two we would call the remote interior angles. Remote interior angles. And looking at the conclusion we got, well, our exterior angle has the same measure, the sum of its two remote interior angles. Let's put that into math. The exterior angle has a measure that is equal to, that is, or the same as, the sum, so that means I'm going to add together the measures of the two remote interior angles. So this one has a measure of 2x minus 5 degrees, and the other one has a measure of, I'm going to add them because we're summing, 8x plus 7 degrees. So 132 degrees has to be equal to 2x minus 5 plus 8x plus 7. We're going to simplify and solve. Here we go. 132 is the same as 2x minus 5. First thing I'm doing, of course, is looking, can I get rid of all my parentheses? I'm doing a little invisible distribution here, distributing that positive across. Positive 8x plus 7. Let's combine like terms. One of my favorite things to do. Hunting around, I see a 2x. I see a positive 8x. Changing my colors because I can. I see a negative 5 and a positive 7. Notice again I'm grabbing those signs to make sure that I get the correct sum. 2x plus 8x is 10x. Negative 5 plus 7 gives me a positive 2. Two-step equation. Let's move the constant on both sides first. And let's divide by my coefficient, and I get 13 is equal to x. I could go back and check. I could go back and find what those actual angles are. But for right now, I'm done. I found x. Although I'd expect you to do a check. And next way that we would maybe see putting this into action, we're going to find the measure of angles D and K. So now you can see I've kind of given us a parallel line setup here again, but I've adjusted it so my triangle is just sitting along one parallel line and just barely touching the other one. So I've kind of gotten rid of those transversals as lines, and instead I'm putting them as line segments. All right, in this one I see, ooh, be careful. You're going to say that 47 is an exterior angle, but it's actually not. Yes, it's outside of the triangle, but it is not supplementary to one of the angles. So we only have one exterior angle over here, and that one is the 74. This guy is my exterior angle, and he has to equal the sum of his remote interior angles. That is, of course, would be K and D in this place. We're going to put in remote interior angles, or our eyes. Sure, why not? Grid. So we have that. So now how do we make use of this 47 in here? Well, the way we're going to make use of that is that the 74 that I see over here actually tells me that I know, let me grab a different color, this angle has to be 74. Alternate interior angles are here. You could also see this if I extend up, and this is my corresponding angle 74, and then it would be vertically across. That whole thing is 74. So that means I can write this guy down. 74 is the same as 47 plus whatever D is. I can solve for D from here. Subtract out 47, subtract out 47. We are left with a little bit of side math that we did correctly, perhaps. 6 minus 4 is 2 equals D. Let's put a victory box about that before we move on. And now we can take advantage of the fact that we know that the exterior angle is equal to the sum of the two remote interior angles. We know what D is. D is just 27. So let's go ahead and plug that guy in. D equals 27. Let's solve for K. Minus 27, minus 27. Another math over here that we're going to do. Ooh, look at that. It's a 47. How special. So yes, there's another way that we could do this, because there is not just one right way to do math. If you see the other pattern, awesome. Use it. If not, no worries. Alright, so that was exterior angle theorem and how we might apply it in two different ways. Happy exploring. And next, or the last thing we're going to do with this is we're going to just touch back on similarity.